Good afternoon, everyone. So this is your instructor, Dr. Bo Li. So I'm the teacher for this course, CSC 413, Introduction to Computer Algorithms. In short, we just call it algorithms. So this is a very important course in our computer science program, and I will use one semester to introduce the basic algorithms and how to design and analyze algorithms efficiency and also space requirement. So we talk about two things in space efficiency and time efficiency. In short, we just call it efficiency. So for our algorithm, we have to know how to design an algorithm. This is the first one, design. Okay. But the second one, once you design the algorithm, you also need to know how to analyze. That means do an evaluation whether your algorithm is good or not, whether your algorithm is better than the previous one or than another algorithm. So we have to use some method to evaluate. How to evaluate an algorithm? We call it analysis. So ANAS. Okay, analysis. So analysis, we just talk about we have space and time, but the time is the most important compared to the space. Okay, space, of course, is just memory. That means how much space you need to use for your algorithm. If you use maybe n square, another one use n, of course, your algorithm is less efficient in terms of space efficiency compared to the other one. And so these are the two important things: design and analysis. Okay, your algorithm has a good design by following some guidelines, just because you have knowledge and also you know the strategies to design algorithm. For example, later we'll talk about divide and conquer, greedy algorithm, graph algorithm. And the other one is that okay, you analyze your algorithm, it is have good efficiency in terms of time and space, or at least in one aspect. So third one is that you have to make sure your algorithm is correct. So that means we have to prove the algorithm is correct. So this is the proof. So in fact, we will center our course around these three aspects of the course: design, analysis, and proof. Of course, we will have more expectations on the first two. Okay, design and analysis. So that means you will encounter many new problems. You learn this course, you know traditional strategies to solve similar problems, but your problem will be different from the algorithm settings we learned. For example, we use this divide and conquer algorithm to do a sorting, but maybe you have another algorithm. You can classify, you have another problem, you can classify that problem into this type of problem. Maybe it's not really sorting, but you still can use the divide and conquer strategy to design an algorithm for your own problem. So we learn to solve new problems, right? We don't learn for knowledge itself. Okay, so that means the design part is the core part. We will learn many strategies. Will not cover all of them, but will cover most of them. So you have the ability to learn by yourself after you finish this course. This is also our expectation. So you also need to know how to do analysis, because even after you finish your program, you will have interviews by companies when you are hunting a job. So they will ask you, okay, what is the complexity of your algorithm? This means you have to do analysis of algorithm. What it means analysis? Just like we mentioned, efficiency, right? Whether your algorithm can be further improved in terms of space and time, because memory is easy to solve, but time cannot be easy to solve, right? If you can reduce your time efficiency, means time complexity, you can get a better chance to go to the next round. Okay, so this is the important things. And sometimes we can, for example, you design algorithm and have good time or space efficiency, but maybe you don't want to implement it first to prove it is correct. Because even you implement algorithm, you can only use testing, correct? Testing means you can just feed the code with cases, test cases, but you cannot exhaust all the possible cases for a problem, even for example like addition, a plus b, correct? Can you exhaust all the possible cases for the addition? No, correct? You cannot do that within limited time. Okay, so that's why we need to use a theoretical way, because this is the final solution to prove an algorithm is correct. So that means you also need to prove your algorithm is correct. So correctness proof, this is also our one of the three important things to consider in this course. And also, as you know, algorithms is the core part of our computer science major, right? So that means you can consider anything like an operating system I offered last semester, and AI courses as well. So they involves essentially is algorithms, right? For operating system, how to do the CPU management, scheduling, how to do the memory management, so memory allocation, and the AI, for example, how to do a search, how to do a machine learning algorithm. So this is the core part of our program. So we always talk about algorithm. Algorithm means you want to find a finite set of steps to solve a problem. So you can use this algorithm to communicate with others. Okay, you don't need to implement. Maybe you just design the algorithm, and design means design, analysis, and proof. These three parts, and then you can hand it over to another engineer. Maybe that engineer or several engineers will implement your algorithm. Correct? So this is like a general presentation how to solve a problem. So that's why you know why it is important. As a whole, our computer science, we can think about this as a tool, correct? You can think about it as the information processor, or you can think about it as a tool. So we want to solve problems. We want to solve problems in any field we can do, correct? So finance and education, retailer, anything, correct? So that's why we can find computer science is everywhere. Okay? Computer engineers can work for any sector in our life. Okay, so this is like an open mark for this course, just to give you an overall introduction about this course. So I'm not new to you, maybe I think to most of you, correct? So maybe you have learned together with me in several courses before. So I may not just want to spend much time in introducing myself. So if you are interested in my background, you can just visit my website, personal website. It has my vital, correct? My resume. So my previous work, teaching, and also maybe research as well, in case you have interest in doing research with me, correct? Also you can contact me. So my research is about visual computing. So basically it's just like you want to use computer to process visual information. Visual information means image, video, and graphics, correct? Like these things, 2D, 3D, and 4D, like this. 4D means video plus maybe 3D plus time, right? 3D information game, but if it's a 3D game, video game, okay, is a 4D. So my interest is about this. Overall, you can think about the broad area of my research is AI, correct? AI. Okay. So I will explain something when we talk about the syllabus. So here is just like open marks about this course. And then we'll talk about this one again when we go back to the slides. So usually my tradition is that I will go over to the course syllabus first, and then we dive into the contents. And usually I think the course syllabus lecture is the most important course, most important lecture in all of the lectures, because it will give you an overview, and also will provide introduction, expectation, learning strategies, and important things, hard things, and put this course in a big picture. What is the connection between this course and other courses in your program? So I believe this is the most beneficial one. Do not miss the first course. Especially do not miss the syllabus video. Okay, let's if you click this one, you can open the course syllabus, because I have opened this one, so I can do this one directly. So before the start of the course, I will just introduce your classmates. So I don't have time to call your name, so I will just, for example, share the grade roster and also the photo version cut. So in fact, I already shared these two documents in the syllabus folder in your files. Okay, if you open, for example, you open your course, right? And then files, because usually I use this one to upload materials. So if you click, so we have this thing, right? So slides, syllabus, and some additional announcement. Okay, slides is here, so upload it to here. Syllabus, I put the roster into this folder. Okay, you can click and then to see. Why I want to introduce this one, we cannot see each other. Even you can not see your classmates, because we are not in a traditional setting to learn the course. So maybe you want to discuss with some classmates in solving some problems, correct? So we who are in the same class, who are your classmates. So in total, currently, so far, we have 27 students in this course, and this is the roster. So the pictures version, correct? Of course, somebody don't have pictures. Okay, so I don't know. It's better you put your picture there, so people know your face. It's better just have no photo is empty. Okay. And I believe I counted maybe 80% of them, at least 80% of them are already in my previous class. We still have some new friends, okay, new classmates, of course. So I think maybe we can save our time, correct? So you can just look at this one. So overall, this semester for this course, I don't have a collaborated project. So that means it's independent project. Everybody needs to do his or her own project by himself or herself. So but does not mean you cannot discuss with your classmates. So go ahead and then connect your classmates. Okay, so we just skip the attendance. Don't call your name, but I know you. I know each of you, and I take care of each of you. I care each of you. Okay. And due to the remote teaching, so we go over this syllabus first, and also want to introduce more content to you. I will just go through as quick as possible. Want to enhance the most important thing. Okay. So I will just point out the important things in this document. So you have to read the documents from the first line to the last line carefully. This is the important document. You may go over to it. If something happened, we may do some changes. We may have voting and then to change, because this is the important document, like contract, cut. Of course, I don't have a real contract with you. I think like contract, that means we have to follow the expectations. Teacher will follow the things here, and the students also will follow the things here. Okay, rules, expectations, assignments, timeline, and so on. Okay. So the first important thing is that we have the instruction materials release day is Thursday. Though today we deliver the lectures, but it's not the usual case. So in the later cases, later weeks, I will try my best to follow this one, if without any urgent things. Okay? So try to at least deliver the lectures by the end of the day, Thursday. Maybe it's possible I will deliver the unit delivered by the just in the evening, because I know because this course unit is offered in the evening after you finish your work. Okay? So, but I will try to deliver it earlier. So that means you can prepare and you can start to learn maybe from 6:30. Okay? That's our usual time for the light class. And each week we have 3 hours. That means in total is 150 minutes. So credit hours. 1 credit hour is 15 minutes. I usually divided the 3 hours into 2 instruction videos. That means each one is 75 minutes. And sometime, maybe due to technical issue, I may just upload it. Some messy means not really evenly divided videos. Sometimes maybe it's only 60 minutes, maybe 30 minutes, because I use the Canvas to capture real-time videos. Sometimes there's some technical issue, like the network issue or the software issue, okay? But I don't want to waste the captured videos, so sometimes I will upload those segments as well. But in total, we have 150 minutes for each week. So I will only just release the videos one time. That means within one day, if without any special case. And another important issue we want to know is that we have the Zoom-based online for office hours. This is the same as last semester. Okay, so I will just for example, will be ready to meet you during this time. And this case, the new thing is that I also provide the Zoom meeting information in case and you don't know where to find it. And I will, similarly like last semester, I will also make an appointment with you, all of you, via the Outlook calendar. So that means I will make a Zoom meeting appointments for every week in these time slots. So from 9 to 12 and 2:30 to 4:30 for Mondays and Tuesdays. Okay, because okay, I think maybe I have to change this one a little bit. Sorry about this. I may change to be Monday and Wednesday. Yeah, I forgot to change this one. Anyway, I will let you know. I changed this one when I upload a new version. It happened. Sorry. And just because this time I chose a new time for our course delivery for the 2 courses. Of course, one is still the same. And I chose Tuesday and Thursday for my 2 courses. The other course is database. I believe many of you are also in the course. So Monday and Wednesday are available for me to meet you. Okay? So I have to change this one. And the meeting information is this one. Okay, so you click this one and meeting ID and passcode. Or you can just use your Outlook calendar, and then you will automatically have this meeting information, maybe give you a reminder. And the important thing is that sometime maybe because you can, if I keep listening, maybe have some impact on my working, right? So it's great if you can send me an email. So during this time I will be beside the laptop. So if you send an email to let me know you want to meet me shortly, or at what time, or approximately what time, at least maybe 5 minutes before, right? And then I will enter or open, right? Not mute the Zoom meeting, because it lasts for 2 days, right? So that's why just provide some convenience for me. Just send me an email, and then you want to meet me to discuss some questions. Of course, email are also available. You can always send me emails to ask questions. If you prefer a face-to-face meeting to discuss some question in a thorough way to help you finish your homework, we can do face-to-face meeting, because that's maybe the more convenient way. You may also want to have opportunity to discuss some other things which you think I may help you. It happened in the previous semesters. Students have something seems I may be a good resource to ask for. You are always welcome to talk to me. Even like some students who already graduated, they also contact me, because that's the reason, that you have teachers. Your teacher just want to see you grow, want to see you become stronger and stronger. You become better and better. Okay. And the email, phone information. Sorry about that. Currently I maybe have not set up the forwarding. I believe I will do that if I can. But I believe Zoom meeting is also very convenient. So you can try to use Zoom instead of a phone. But anyway, I will. It's good to do the phone forwarding as well. And for this course, we have a prerequisites. So basically, of course, data structure and math will be important for this one. But I don't think it is a must. Right? It's better you have this knowledge. Why? Just because you have to use that knowledge to smoothly implement some project, and maybe understand some matters, some algorithms. For example, I think this is data structure. Let me just confirm. Data structure and algorithm. But anyway, this is mainly data structures. So so where we call this is important. So we have a form called this way. So what is a program? So usually we say it's a data structure plus algorithm is equal to software or program. You can just, in short, maybe a lateral scope is a program. Is it correct? You want to use some data structures to represent something, right? You are doing sorting. Okay, you want to hold all the numbers into an array or into a tree, right? So if you use a binary search tree, but anyway, this is the data structure. That's why you may think some overlapping between the course textbook and your previous data structure textbook, right? Because data structure is the prerequisite for algorithm. That's why maybe the algorithm course textbook also contains some prerequisite knowledge in the textbook. Okay, so data structures plus algorithms. So data structures is like how you will store the data, and also of course it will help you to manipulate the data. It will easy to process data. But to solve your problem, you still need to have information processing steps. Right? You will do sorting first, and then you will do maybe something else. Maybe it's a select, it's a search, maybe again another one is can find the optimal things, so optimization. So these steps is algorithm, okay? So this is like a container. Okay, you have a bowl which can put rice or dishes or vegetables inside, milk, anything, right? But how you stack the bowls and then make a nice picture and then let people eat, have a good appetite to eat your product, okay? So that means we have algorithm. Okay, you need to eat a soup first, and then eat a vegetable, and then eat a fish, eat what, okay? This is like you have a menu, or you have a steps to finish your dinner. Okay, that's your program. Okay, if you teach somebody to eat, okay, first put the bowl, and then put the rice into it, and then put another plate, put vegetables, fish, and meat, and so on. Okay, step by step. Okay, and then eat. After eat, wash them, and then finish. So this is just the program. Right? You will teach your program, your code. Okay, code your kids, and then the mind. Okay, our brain will be coded. So we don't need to be teach again. That's why we want design software, design program, because this is the reason, which is general, which will be easy to communicate. Okay? Will be used again and again. You will teach this one, repeat this process for each kid of your family. Okay, just like a simple analogy like this one. So this one is general. It's very interesting. In fact, when we talk about computer science, it's not a very high tech knowledge. We still use our daily life experience to design the algorithms, like the one we mention a lot, divide and conquer. Sometimes we don't know how to solve a problem. We want to make the problem smaller to easily handle it. So divide it into small problems, and each one will be handled separately. After that, we combine the solutions of all the small problems together to get the solution for your original big problem. That's the reason that's also the same way, right? We handle our daily life. Okay, so use your own daily life experience in understanding the strategies here. That will be very beneficial according to me. Like maybe sorting, because it's very beneficial, very popular. We use it very often. So we have different sorting algorithms. So dynamic programming is also have some foundation in our daily life. So a small problem build up a bigger problem, and the bigger problem build up an even bigger problem. So when we solve problems, we may solve small problems and use the answers of the small problems to get an answer for big problem. So this is also the difference between divide and conquer and dynamic programming. So divide and conquer, the small problems are independent. For example, you do the counting. Right? If you want to count how many students in USM, you can count each class separately. And then when you count class 1, you don't need to consider class 2. You can use CPU 1 to count class 1, using CPU 2 to count class 2. They are separate. They are independent. So the answer to the class 1 does not have impact to the answer to the class 2. But dynamic programming is different. So this is independent. This is not independent. Okay, so that's the difference. So not independent means the bigger problem to be solved, we have to have the answer of the small problems as an assumption. You have to solve the small problems first, and then you can solve the big problem. And your original problem need to solve big problems, and big problem need to solve even smaller problems. and till the problem you can solve. So you will do this step by step, and maybe you will solve small problem again and again. So you don't need to solve it again and again. You save the answer of small problems. Okay, so this one maybe you can think about like a string matching. For example, two strings, yeah, A, B, C, D, E, F, G, and so on. What's the maximum common sequence between these two strings? And also you can solve maybe like a search common things between two particles, like these things. We use dynamic programming a lot. Okay, so anyway, this is just like a extension of our thing that we want to talk about. Okay, so we talk about this design strategy in detail in these slides again when we finish the syllabus. But here, just want to, when I reach there, we want to let you know what's the things we'll learn. So we'll learn the strategies here. So define and conquer, sorting and search, dynamic programming, greedy algorithm. If you don't have an approach to solve a problem, you cannot use define and conquer. Sorting, no, not sorting, not possible, is not a sorting problem. Also, you cannot use dynamic programming. Then you can use greedy algorithm. Why we use greedy algorithm? Just because we don't have algorithm. That's interesting, right? If you don't have algorithm to solve some complicated problem, at least greedy algorithm will give you an answer. We don't know whether this answer is the optimal or not. Optimal means the best, right? Is the shortest, is the minimum, is the maximum, is the top, is the most like this extreme case, okay? So because that's the unit used to solve optimization problem. At least, okay, it will give you an answer. And if your problem meets some optimal structure, this greedy algorithm can guarantee the solution will be the optimal. That's great, right? That's the reason. And then graph algorithm, just because we have some problem which are falling in this category. So for example, like finding the shortest distance between Long Beach and New Orleans, or Long Beach and Harrisburg, or Long Beach and DC, right? Even longer. So in fact, the data or the problem itself is a graph, because we cannot jump from one city to the other one. Use helicopter, we are saying driving, right, or walking, like these things. We have to follow the roads. If you follow the roads, then between two cities, if there's a road, this is called like the edge between two vertices. If you have many of them, and then you will have a graph. So in fact, for your case, is find from a starting to an ending vertex. What is the shortest distance between this starting and the ending vertices? Correct? Your source and the destination. When we talk about the graph algorithm, we use this professional word called the source and the destination. So your target is to find some extreme case between a source and the destination. If like that, and the other problem can be represented as a graph, then graph algorithm will be a great source for you. Usually we use some general algorithms used, maybe you have learned before, BFS in AI, correct, in data structure. So BFS, breadth first search, or DFS, and depth first search. But we have something more we will talk about again. We like a Dijkstra algorithm and some other applications for graph algorithm. For example, find the minimum spanning tree and so on, like this. For example, you want to build cables to connect several cities using internet, for internet. So what is the smallest cost to connect all of them? So you have a graph, but you don't need to connect any two cities. You just need to connect like this way, correct? Or this way. So what will be the shortest distance to connect all of them? Shortest distance means shortest cost. So you will of course you will add all the edges you will include in your solution, and then add them together. What is the shortest total distance? Okay, and then we also talk about if we have time, right? But this is like optional ones. So later we will talk about these things in the syllabus as in detail, like NP problem, non-polynomial problems, deterministic problem. That means you cannot solve this problem in a polynomial time. Polynomial time means n square, n cubic, or their combinations. This is called a polynomial. This is measure the space or time. Here, usually we talk about the time, right? And the stream matching, in fact, it is used in the dynamic programming and the applications. We mentioned about the minimum spanning tree and the Dijkstra algorithm, find the shortest distance between the source and destination. And the sorting algorithm, we'll talk about the merge sort. And if we have time, we talk about a quick sort. So merge sort is an application of the divide and the conquer. In fact, merge sort. You may have learned another algorithm before, quick sort, but then maybe you not ever heard another algorithm called a heap sort. So we'll cover heap sort as well. So basically, the things we'll talk about is that we have an introduction, of course, and then we talk about how to do the analysis. So we talk about asymptotic notation, how to do the analysis, which we will talk about maybe theta, omega. Later we'll explain this one as well. That means what is the complexity group for your algorithm? Is a linear or like the quadratic one, n square, or cubic, or log n, like this, cat, or n log n. For example, like merge sort is n log n complexity. So this is just to help us to evaluate our algorithm. So this is in the chapter 2 of the book. And after that, we talk about define and conquer, and then merge sort, quick heap sort, and then the dynamic programming. We also talk about stream matching, and then graph algorithm and greedy algorithm. If we have time, we'll cover some other advanced topics. So for each algorithm, we talk about the design and the analysis and the proof. Keep in mind, okay, that's the 3 important things we talk about just now: design, analysis, and the proof. Always keep in mind you have to do all of them for each new algorithm. How to design, you need to learn the strategy that will be covered in this course. And how to do analysis, you will learn the asymptotic notation, like we mentioned, theta, omega, and of course you have more. Okay, big O, small o. Small o is a special case of big O, and theta, tight bound, and lower bound, tight or not tight, and small omega is lower bound but not tight. Then big O is upper bound, tight or not tight, and small o, upper bound but not tight. So these strategies we'll learn. Okay, later we'll give the definition for each of them. This is math. That's why we'll talk about we have prerequisite data structures and the algorithm, right? So data structures is important. And then for these things, you have to know some math. Okay, that's a pity for you, but that's a must for you. And really, I think math is the foundation of our course. You have to have a solid background in understanding our courses in this major. So it's also easier for you or better for you if you can learn the math courses as soon as possible. Do not delay the learning of some courses when you are almost finish your program. Correct? Finishing your program. For example, in the past, I have this concern. Some students didn't learn the probability course and put that course in the last semester. That's a waste. Because if you have learned this course, I will teach you Bayes network in AI. But if you don't learn this one, even I teach you probability, but it's still challenging for you to understand the Bayes network. Because the probability and statistics, that's the foundation for you to understand Bayes network, which involves all of them, just probability things. And of course, this may be also due to our program design issue. We will try to improve this one. But anyway, in case you want to use or learn by yourself for this type of things, when you are learning those courses, if you already have the knowledge, that will be greater thing for you. You don't need to wait till you graduate to learn, because it seems like AI and many things, they will have some mess. Okay? Yeah, even you know how to code, how to train a model, but we are still expect you to understand why it works, why it cannot work. Can you give me some general rules to train your models, train your algorithms, to design algorithms? So all of these things called formation, correct? So this logical formation need to have math as your background, correct? Because we use math to formalize things, correct? Addition, subtraction, like these things, or optimization, and so on. Okay, that's why we put this one as a prerequisite. And the next one we talk about, okay, the catalog description. So it's very short. Study of recent advances in algorithm design analysis. But we already mentioned about what is the topics for this course. Topics: design, analysis, and proof. That's the topics. Which strategy will be learned in this one? Mainly is define and conquer. And then we will learn the graph algorithm, greedy algorithm, and what else? And dynamic programming, DP. So define and conquer and dynamic programming, you can think about it like a group because they are related but different. And then we have greedy algorithm to solve the other case. If we cannot find the extreme case, we cannot find a good strategy with greedy algorithm. Greedy algorithm, that means every step you choose the best according to you currently, correct? That's greedy algorithm. And the other one is special one, graph algorithm. Okay, graph algorithm. So that's also to handle some special case. It's also very popular in our daily life. Yeah, so that's why we also cover this one. Of course, we have some more, but the book is very thick. We cannot cover this one even in 2 semesters. Okay, that's why I believe in this course, my expectation or your expectation, your practical expectation, okay, is to just like I want to open a gate for you. For all my courses, I also want to have this one. Open a gate for you and teach you general things. You have the ability to learn by yourself for advanced topics, or even for the future. This course contents have been changed due to the development of science and technologies. Even the textbook will be changing. So you can learn by yourself because you have the ability to understand the book by yourself. That's the reason we want to have a degree. Correct? Also, I think this is the most important thing for a student to have a undergraduate or be a bachelor degree. Right? Learning ability, okay, self-learning ability. So teach you how to eat, and then you can eat anything. Not only fish, you can eat something else. Right? Okay, and course description. So basically, we have learned this. We have talked about this one. This is the core course in our program. Okay, it will be everywhere. Right? They are important. And also, just maybe some of you already have experience in interview. So when you are interviewed by a person, okay, recruiter in a company, they will anyway during the maybe several rounds, first round, second round, phone interview, they will first round maybe not challenge you algorithm design ability, but later, for example, you are invited to have an on-site interview, or you have entered the second round, you have a coding interview. Coding interview means that means the second round they will ask you to solve a problem. Of course, you can use some online resources, use collaborative software. Okay? You code on one side and use Google document and so on, and then they will examine you. You need to solve the problem, for example, like how to find the minimum number based on a BST. So it's a binary search tree. Right? What is the minimum number if you already have a binary search tree? So binary search tree, just let you recall. So help you recall if you learn the data structure. So you have the root, you have left and the right leaf. So binary search tree means that the left is always less than the root, than the parent, and the right is always bigger or less or equal, or bigger or equal, okay? Bigger than or equal to. So this is we construct a binary search tree, okay? Not a binary tree. Binary tree means every parent have at most 2 children. That's called a binary tree. If binary search tree, that means beside the binary tree, we have this additional requirement: left, and then middle, and then right, sorted, okay? Like this way. So they will ask you like this. Okay, you choose what algorithm, what effort. After you design, they will ask you, could you run this thing manually, run your code manually, do not have a compiler, and run a case whether it can find the correct answer. So this is like a proof, okay? Correctly proof. Correctly is proof, but this one is not a formal proof. It's like a test case. So it's like a software testing. If you have learned software engineering, it's only one stage of software development. Is about the testing. And again, they want you do further improvement. They will ask you, maybe it's very possible, could you further improve your algorithm, make it more efficient? Okay, you will just maybe think another algorithm will change the data structure, change the algorithm. Anyway, they also have a time limit. You have to solve this one maybe within half an hour, within 25 minutes or 15 minutes. So anyway, this is important for your future, just because you need to use this one as a brick to open the door for you, okay? To lock the door for you. Okay, you need to enter the door. So you need to get an offer from the company, your dream company. Okay, so this is important. So later, when you are at either you want to pursue your advanced degree, master or PhD, or in the industry, you will always have algorithms there, I believe. Okay, because you cannot avoid algorithms. Even hardware development, sometimes they also have algorithms. Okay, they may just coded something into hardware. We call it firmware, and then we implement something else as real hardware to improve the efficiency, make it quicker. Okay, so this one is a core part, and then we'll talk about the most important strategies and the 3 aspects of algorithm topic, and also talk about applications as well. Okay, 3 aspects: design, analysis, and proof. And the important strategies we mentioned about define and conquer, dynamic programming, and then we have greedy algorithm, we have graph algorithm. We may cover something else, applications, like a stream matching, shortest distance, and optimal optimal solutions for some problem optimization. Okay, and other things I think you can read it by yourself, because I already give you the repeated the idea. Okay, analyze, compare means do the analysis, which one is more efficient in terms of time and space, and determine a appropriate strategy for utilizing algorithm given both time and mandatory constraints. That means, for example, if you have to design algorithm, you also need to consider your environment. Are you designing algorithm for a PC, for embedded system, for a cell phone? Okay, like cell phone, they are totally different, because one is like resources. You can think about resources don't have much constraints, many constraints, but the other one is called resource limited. Okay, resource limit like a embedded system. Whether it's for the plants, for the production control, or for our daily use, like the cell phone. Okay? The battery is limited. The power is limited. The CPU capacity is limited. The display is limited. Even the singular. Okay? The wireless, the network is also constrained. The bandwidth. Okay? All of these things will be considered when you design an algorithm. Do not design an algorithm without considering the environment. You have to design an algorithm with the limit of the available resources. Think about after the software has been deployed, what will happen? What will happen, and what will be considered if you design the algorithm. So do the things correctly first time. That means in the beginning. So this is really a lesson for everybody. Okay? If you don't do the things correctly in the beginning, you will spend more time, and also maybe the result is worse in the end. Okay? Later you will spend more time. You will do maybe repetitive work, repetition. Okay. So next one, the textbook. This is required. So this is if you can find of course you bought an electronic version is also fine with me. And anyway, you need to have a book. Okay, this one, because I will accommodate you if no problem. Just when I assign the homework, I will put the I put the problems in the document as well. That means make the problems available to you, the problems themselves, the text or anything. But I still believe this is a good investment, because this is the Bible book for the algorithms. I believe maybe most of dominating schools using this book. Okay, over the world. Is not only some. Okay? Of course, we have some other good reference book, but this one is the best according to me. Okay, according to many people, not only me. So in short, we call it CLRS. When we talk about the schedule in the end, we just refer this one to CLRS as well. Okay, CLRS, just the first name letter, okay, first letter of the first name of the authors, CLRS. Okay, though the book is old, compared to the time now, it's 2021, but the algorithms themselves don't have much changes. Many changes in the past. We may have new algorithms, but the most basic ones are still the same. They are basic ones, means they are more important, they are more useful, they have more cases to be applied in our life, in our work. Okay. So this is a thick book. I don't expect you read a page from page 1 to the end. Even for me, I haven't finished all of them. But I will ask you to read the book for the chapters we have covered. For example, chapter 1, 2, 3, like this, and cut the initial chapters, because they are important for you to have a thorough understanding. If you, for example, you can only use 3 hours to understand everything, then you will become very rich, because you will you will become you can do anything, because you can use 3 hours, and then there's no need to practice, no need to work by yourself, no need to read the original text. Then you are really really powerful. You can exhaust every knowledge within very limited time. Then you can do everything. I believe you can become very great person. You can lead our world, because that's really the hero of our people. We need to have those people, but it's it's not possible, I believe. So that's why we need to have other things required. Okay, just read the book. They will be very beneficial. This is not only my own understanding, it's also based on the experience from some previous students. They invested in books and then found that they're really beneficial. So do not just count on myself only. You need to count on big guys like these authors. Respect them, of course. I need to respect them. Without this book, I may not be able to teach a good course. And also read the book before you. Of course, maybe you don't have time. You can skip the preview. So, but after the lectures, you have to read the book. That's also beneficial. According to my learning experience, they will be very beneficial. You will have a very solid understanding. You may clear some questions you have during the lectures. Okay, and the next ones are the optional books. Optional books are only provided for just references. I listed them just because I believe they are important reference. They may be beneficial for you, maybe in the future as well. You know this resource, so just look at them. I believe I also refer to optional 1 and option 2 in the schedule in the end of this document. Okay, we can maybe first release this video, and then we'll continue for the rest of this document. Okay, we may just miss the mixed explanation of the syllabus and slides together, but that doesn't matter as long as we finish the thing. Okay, so let you learn first. We will release this video first.